Good day everyone. I am Hazel Dane Elio, and together with my pair Avril Mendoza, we are going to discuss about skewness and kurtosis. For our objectives, at the end of this lesson, you should be able to compute and interpret skewness and kurtosis.
Skewness refers to the degree of distribution deviates from symmetrical or normal. A symmetrical distribution happens when most of the scores clustered in either ends of the distribution. Skewness literally means lack of symmetry, means not identical on both sides of the central line. Thus, it is defined as the degree of symmetry or departure from symmetry of set of data. In a symmetrical distribution, mean, mode, and median are equal to each other. However, in a symmetrical distribution, the tail could be in the either end of the distribution. Positively skewed distribution extends its tail in the right and the bump is on the left. This means the most of the score clustered on the left of the distribution. The relationship of mean, median, and mode is mode to median to mean. So basically, positively skewed is skewed to the right, means it consists of low scores and the scores are always congregated to the left. A negatively skewed distribution extends its tail in the left side and the bump is on the right side. In this distribution, most of the scored clustered on the right side. The relationship of mean, median, and mode is mean to median to mode. So when we say negatively skewed, it is skewed to the left, and it means it consists of high scores and the scores are always congregated to the right. The formula for skewness is equals to n divided by n minus 1 times n minus 2 multiplied by summation of x minus mean divided by standard deviation raised to the power of 3. And its standard error equals square root of 6n times n minus 1 divided by n minus 2 times n plus 1 times n plus 3. The coefficient of skewness will be converted to its standard score or z-score. If the alpha level is set to 0.05, then the calculated z-score must fall with a negative 0.96 and positive 1.96 so that the data approximate for normal distribution. If the z-score goes beyond these values, it means that the data has an acceptable skewness at alpha level 0.05. The z-score of the skewness is z-score is equals to skewness minus 0 divided by standard error of skewness. Example: suppose a company accommodating children's party and conducting a research. A sample of 25 children was selected and the following ages were identified. It is shown in the slides there. Before the researcher further analyzed the data, he or she wanted to find out whether or not the data has an acceptable distribution. Step 1. Compute the mean. In finding the mean, we are going to add the identified ages given by the examples and divided it to the population or sample of 25 children. Mean equals 100 divided by 25 equals 4. Therefore, our mean is 4. Step 2. Compute the standard deviation. In computing the standard deviation, we are needing the summation of x minus mean squared. So first, based on the example chart, the first column there is x. These are those identified ages on our problem stated before. And then again, x minus mean. Keep in mind that our mean is 4. So basically, we are going to subtract the sample ages to our mean, which is 4. 1 minus 4 is equals to negative 3. And after this, we are just going to square the difference. Negative 3 multiplied by itself is positive 9. Same process goes by. In finding the summation of x minus mean squared, we are going to add all product of summation of x minus mean squared. That's why we got 74. Therefore, our summation of x minus mean squared is equals to 74. And now, we have our summation of x minus mean squared. We are able to compute the standard deviation. Standard deviation is equals to square root of summation of x minus mean squared divided by n minus 1. Never forget that 74 is our summation of x minus mean squared. N is equals to 25. S is equals to square root of 74 divided by 25 minus 1. S is equals to square root of 74 divided by 24. Therefore, our standard deviation is 1.755942. Step number 3. Construct x minus mean divided by standard deviation. In constructing this, we are just going to divide the difference of x minus mean to our standard deviation, which is 1.755942. Means negative 3 divided by 1.755942 equals to negative 1.708484677. Same process goes by. In constructing step number 4, we are going to find x minus mean divided by standard deviation cube. We are just going to cube the quotient of x minus mean divided by standard deviation, given by our solving earlier, which negative 1.708484677 is the quotient. Then, let's just cube it. Result to negative 4.98692999. And just like how we did earlier also, let's just add all the product of cube to the result of summation of x minus mean divided by standard deviation cube. Therefore, our summation of x minus mean divided by standard deviation cube is equals to 4.4328 2656. Number 5. Substitute the formula of skewness is equals to n divided by n minus 1 times n minus 2 multiplied to summation of x minus mean divided by standard deviation cube. Always remember that n is equals to 25 and our summation of x minus mean divided by standard deviation is equals to 4.43282656. Skewness is equals to 25 divided by 25 minus 1 times 25 minus 2 multiplied to 4.43282656. Skewness is equals to 25 divided by 24 times 23 multiplied to 4.43282656. Skewness is equals to 0.20076 or approximately equal to 0.20. Step 6. Compute standard error of skewness. Standard error is equals to square root of 6 multiplied by n times to n minus 1 divided by n minus 2 times n plus 1 times n plus 3. Standard error of skewness is equals to square root of 6 times 25 to 25 minus 1 divided by 25 minus 2 times 25 plus 1 times 25 plus 3. Standard error of skewness is equals to square root of 6 times 25 times 24 divided by 23 times 26 times 28. Standard error of skewness is equals to 0.207. Therefore, the standard error of our skewness is 0.207. Step number 7. Determine the equivalent standard score of skewness. Z-score of skewness is equals to skewness minus 0 divided by standard error for skewness. Z-score is equals to 0.20 minus 0 divided by 0.207 is equals to 0.9666. Therefore, the z-score of the skewness is 0.9666. Since the standard score of the skewness is 0.966 is between negative 1.96 to 1.96, therefore, the distribution has an acceptable positive skewness.
So now we were going to proceed to kurtosis. So if skewness means lack of symmetry, kurtosis on the other hand refers to the tailedness and peakedness of the distribution. Kurtosis is associated with the tailedness rather than the flatness or peakedness of the distribution. Though many textbooks strongly associate kurtosis to the peakedness of the distribution, it is the intention of this definition to define kurtosis in its original sense. It is also a measure that describes the tail of the distribution in relation to its overall shape. So now we were going to discuss the types of kurtosis. So all three kinds of kurtosis are compared against the standard normal distribution. The first type of kurtosis is the mesokurtic distribution. So the mesokurtic distribution has a kurtosis similar to that of the normal distribution. So this means that the extreme value characteristics of the distribution is the same as the normal distribution. The second type of kurtosis is the leptokurtic distribution. The leptokurtic distribution is a kind of distribution that has kurtosis greater than the normal. Lepto means thin or skinny. Generally, the leptokurtic curve is characterized by a narrow or thin curve that is taller than the normal. However, its thin shape is only a consequence of the tails of the distribution which stretch along the horizontal axis. This happens when there are occasional extreme outliers appear in the distribution. For these reasons, the distribution appears to be narrow or thin with long tails in both sides. The last type of kurtosis is the platykurtic distribution. Platykurtic distribution is characterized by short tails of the curve. The platy means broad or flat. This characteristic of the curve is due to the fact that the middle scores have almost the same or similar frequency. Furthermore, the extreme values are less compared to that of the normal distribution. In such cases, the curve appears to be short and broader peak. So, the image or the slideshow depicts the comparison of the three types of kurtosis: the leptokurtic distribution, the mesokurtic distribution, and the platykurtic distribution. So to find the coefficient of kurtosis of the data, the following formula will be used. Kurtosis is equals to n times n plus 1 divided by n minus 1 times n minus 2 times n minus 3 multiplied to the summation of x minus mean divided by standard deviation raised to the power of 4, and will be subtracted to 3 times n minus 1 squared divided by n minus 2 times n minus 3. And the standard error of the kurtosis is equals to the square root of 24n times n minus 1 squared divided by n minus 2 times n minus 3 times n plus 5 times n plus 3. The equivalent standard score of kurtosis can be found using the formula. The z-score of kurtosis is equals to the standard deviation of kurtosis minus 0 divided by the standard error of kurtosis. So, example, let us take the given example 6.1, the one that we used in skewness. So the solution, we will follow the steps 1 to 3 of the example 6.1. And for the step 4, we will construct the x minus mean divided by s raised to the power of 4. So that we will get the summation of x minus mean divided by standard deviation raised to the power of 4. So now, the column 3, the x minus mean divided by standard deviation, we have the first value, the negative 1.70455 raised to the power of 4 will give us the value of 8.441786, and the same process goes by. And now we will add up everything in the column 4, and we will have an answer of the summation of x minus mean divided by the standard deviation raised to the power of 4. We will get 62.74019. Step 5. Substitute in the formula. So kurtosis is equals to n times n plus 1 divided by n minus 1 times n minus 2 times n minus 3 multiplied to the summation of x minus mean divided by standard deviation raised to the power of 4, and will be subtracted to 3 times n minus 1 squared divided by n minus 2 times n minus 3. So we will have kurtosis is equals to 25 times 25 plus 1 divided by 25 minus 1 times 25 minus 2 times 25 minus 3, and our value of the summation of x minus mean divided by standard deviation raised to the power of 4 is 63.3221751, and will be subtracted to 3 times 25 minus 1 raised to the power of 2 divided by 25 minus 2 times 25 minus 3. So let us just follow the formula. We will have a value of 3.3892561 minus 3.415020. So our kurtosis will be equal to negative 0.0258. And now we will proceed to step 6. We will find the standard error of the kurtosis. So standard error of kurtosis is equals to the square root of 24n times n minus 1 squared divided by n minus 2 times n minus 3 times n plus 5 times n plus 3. So standard error of kurtosis is equals to the square root of 24 times 25 times 25 minus 1 squared divided by 25 minus 2 times 25 minus 3 times 25 plus 5 times 25 plus 3. So the standard error of kurtosis is equals to the square root of 24 times 25 times 24 squared divided by 23 times 22 times 30 times 28. So the standard error for kurtosis is equals to 0.901721. Step 7. Find the equivalent standard score of the kurtosis. Z-score of kurtosis is equals to the standard deviation of kurtosis minus 0 divided by the standard error is equals to negative 0.0258 divided by 0.901721. It will give us a value of negative 0.0286.